Imagine standing outside during a rainstorm. Now, replace the water with molten glass. And instead of falling down, it's coming straight at your face at 5,400 miles per hour. Welcome to HD 189733b, the most terrifying planet we've ever found.
From a distance, this planet looks almost beautiful. A deep, vivid cobalt blue. Kind of like Earth, actually. You'd almost mistake it for home. But don't let that fool you. This world sits just 64 light years away, tucked in the constellation Vulpecula. It's a gas giant, bigger than Jupiter, and it orbits its star so closely that a single year there lasts just 2.2 Earth days. To put that in perspective, by the time you finish a long weekend, this planet has already completed an entire trip around its sun. Because it's so close, gravity has locked it in place. One side permanently faces the star, baking in eternal daylight. The other side is forever turned toward the cold dark of space. No sunrises, no sunsets, just two permanent faces. One scorching, one freezing. Well, relatively freezing. It's still over 1,200 degrees Fahrenheit on the cool side.
Now, here's where things get genuinely insane. That brutal temperature difference between the day side and the night side, around 500 degrees Fahrenheit, creates a pressure imbalance so extreme that it births winds unlike anything in our solar system. We're talking 5,400 miles per hour. That's 7 times the speed of sound. The strongest hurricane ever recorded on Earth barely touched 200 miles per hour. This planet's average wind is 27 times that. These winds don't just blow things around, they fundamentally change the weather. Deep in the lower atmosphere, it's so hot that rocks, actual rock-forming minerals called silicates, the same stuff that makes up sand and glass on Earth, exist as gas. They're vaporized, dissolved into the air like steam in a bathroom. But as those winds carry that vapor upward and toward the cooler regions of the atmosphere, the temperature drops. And when it drops below about 2,370 degrees Fahrenheit, something remarkable happens. The silicate gas condenses. It solidifies into tiny microscopic particles, little shards and droplets of glass hanging in the upper atmosphere. And then those howling supersonic winds grab them and hurl them sideways at Mach 7. That's the glass rain. Not falling gently from clouds, not drifting down like snow, moving horizontally with the force of a bullet, scouring the entire atmosphere in a permanent, planet-wide storm of molten glass.
Here's the poetic twist, and honestly, the cruelest one. That storm of glass is exactly what makes the planet look so gorgeous from space. Those microscopic silicate particles suspended high in the atmosphere catch the light from the nearby star and scatter it. Specifically, they scatter blue wavelengths, the same way Earth's atmosphere scatters blue light to give us our blue sky. In 2013, the Hubble Space Telescope confirmed this by watching the planet pass behind its star. Blue light dipped noticeably. Red and green barely changed. So the planet's stunning cobalt color isn't oceans. It isn't anything peaceful or serene. It's glass. A permanent haze of airborne glass painting the sky blue while simultaneously shredding everything in its path. If the glass doesn't get you, the air will. In 2024, scientists using the James Webb Space Telescope made a new and deeply unpleasant discovery. They detected hydrogen sulfide in HD 189733b's atmosphere. You know that smell? Rotten eggs, volcanic sulfur? That's hydrogen sulfide. On Earth, concentrations above 1,000 parts per million cause instant death. It shuts down the cellular machinery that lets your body use oxygen. Your cells essentially suffocate from the inside. On this planet, it's abundant. So to recap the atmosphere,
Scorching temperatures, glass shards at Mach 7, and air that would kill you in one breath. Oh, and there's no ground to stand on. It's a gas giant. You just keep falling inward until the pressure crushed you into something unrecognizable. Let's be honest about what survival would look like, or rather, wouldn't. The moment you entered the upper atmosphere, the glass would hit first. NASA described it as death by 1,000 cuts, and that's being generous. At those wind speeds, even a particle smaller than a grain of sand carries enormous kinetic energy. Millions of them would strike you every second. It wouldn't be cuts, it would be erosion. You would be sandblasted out of existence within heartbeats. If somehow you survived that, which you wouldn't, the heat would carbonize you on contact. 1,700 degrees Fahrenheit is hot enough to melt aluminum. Human tissue doesn't stand a chance. And if somehow you survived that, one breath of the air would end it. This planet is not hostile to life. It's hostile to matter.
So why do we care about a planet that would destroy us before we could even register what was happening? Because HD 189733b is a laboratory, a place where the laws of physics are pushed to their absolute limits and where we get to watch what happens. By studying its winds, we learn how atmospheres move heat. By studying its chemistry, the sulfur, the carbon dioxide, the water vapor buried beneath the haze, we understand how planets form, what they're made of, how they evolve over billions of years. The models we've built from this one blue nightmare are now helping us study smaller, more Earth-like planets elsewhere. And in a funny way, HD 189733b reminds us just how remarkable Earth is. Our gentle vertical rain, our breathable air, our unremarkable, forgettable, perfect weather. From 64 light-years away, HD 189733b looks like a calm blue marble hanging in the dark. But now, you know the truth. It's a world of supersonic winds, poisonous air, and an endless, howling storm of glass, moving sideways, always sideways, across a sky that will never see a sunrise. Beautiful, deadly, and more alien than anything we could have imagined. That's the universe we live in.